going to do next is be able to use this information to outline where the electrons are for any given element. The reason that we're going to do this is because this is what will let us start to be able to predict bonding, especially when it comes to covalent bonding. So let's start again with our traditional periodic table. Which we have here, and we're just going to start sort of in order, talking about doing the electron configurations for one element after another. And so literally, I'm just going to go in order. So we'll start with hydrogen. Hydrogen has one electron, and so that one electron will go into the first orbital, which we know the lowest energy orbital is the 1s orbital. So we designate this as 1s1. We can go up to helium. Helium has 2 electrons, and for something with 2 electrons, we can fit 2 electrons in every orbital. And so that 1s1 for hydrogen, that 1s can take a second orbital, or second electron, and so it's 1s2. Now we can jump down to the next row for lithium. Lithium has 3 electrons. Now remember, each of the s orbitals can hold up to 2 electrons. So the 1s was already filled with helium. So then we go to the next orbital. So 1s2, and then 2s1. After lithium is beryllium. Beryllium has 4 electrons. So 1s2, 2s2. If we go up to boron, now with 5 electrons, the 1s is filled, the 2s is filled. So where does the next electron go? Goes into the 2p. And we just keep going on like this. And we fill each orbital, and after we fill each one, then we go to the next one. So let's jump down and do something more complicated now. Let's do iron. So iron has 26 electrons. So 1s2, 2s2. Then as you saw, we go on to 2p. How many electrons can the 2p hold? 2p can hold a total of 6. So far, we can keep a running total. That's 10 electrons. Next is the 3s. That holds 2. Followed by the 3p, which can hold 6. So that's 8 more. So we have a total now of 18 electrons. Where do we go after the 3p? So remember, we don't go to the 3d. We first go to the 4s. That holds 2 electrons, just like the 3s, the 2s, and the 1s. So we add those 2 in. Now we're at 20. We have 6 electrons to go. The next orbital after the 4s is the 3d. The 3d can hold up to 10, but we only have 6. So we put those last 6 into the 3d, and that's our electron configuration. What starts to happen though, especially as we get to higher and higher numbers of electrons, is that these electron configurations get really long. And so what we look for sometimes is a shorthand way of doing this. And the reason we look for this shorthand is some electrons are more important than others. Which electrons are most important? Well, it's what we call the valence electrons. These are electrons specifically in the highest energy level. So it's a little less clear to see here, but if we go back to the previous page, for example, lithium. Lithium has 3 total electrons. But how many of them are valence electrons? Well, 2 of them are in the first energy level. 1 of them is in the second energy level. So only 1 of them is in the highest energy level. So we say it has 1 valence electron. For beryllium, 2 are at a lower level, 2 are at a higher level. So it has 2 valence electrons. Boron has 3 valence electrons. And one of the patterns you'll start to see as you look at the periodic table is that we see a lot of patterns. Everything in this first column, group 1, ends with S1, and they have 1 valence electron. Everything in this second column ends in S2, and they have 2 valence electrons. Anything in this group, group 11, is going to end in D9. When we get back to our main group, for example, group 15 containing nitrogen, these will all end in P3, and they all have 5 valence electrons. And so it starts to make even more sense, the organization that we have. But as I was saying, some electrons are more important than others. And we want to single those out. We want to draw our attention to those, the valence electrons. So we have a shorthand notation of doing electron configurations. And that's, we only worry about the valence electrons. So for iron, which we just did, we take where iron is, and then we're going to look backwards. What is the noble gas that comes before iron? And the answer is argon. So argon has a configuration 1s2, 2s2, 2p6, 3s2, 3p6. So the shorthand or abbreviated notation for iron will take the noble gas that comes directly before it, which is argon, and then just show us the electrons that come after. So argon 4s2, 3d6. Again, this saves us from having these drawings of configurations that are extremely long and also only points out what's most important. So now you should get out in class exercise number 9, labeled Electron Configurations, and start working on some of those practice exercises.